Good day, math learners. Now we are in the second part of our topic with mathematical logic, specifically the operations of propositions. In this learning pocket or in this video, we will be focusing on the operations of propositions. Now here are our objectives in this lesson. First, we will be performing the different types of operations and propositions. Next, we will determine the truth values of proposition and illustrate the different forms of conditional propositions. Recall that a simple proposition is a statement with truth value, whether it is true or false. Operations involving two or more propositions make use of connectives, and combining proposition using connective will result in the form of a new proposition. To determine whether this resulting proposition is true or false, a scheme of listing all possible truth values will be used. This scheme can be done with the help of the so-called truth table. Truth tables are a way of visualizing the truth values of propositions. And a true proposition is represented by T and F for the false proposition. Now let's start constructing our truth tables with conjunction. So conjunction, so you have here P and Q. This inverted V symbol represents AND, or can be read as AND. The rules is the conjunction of two statements is true only if both conjuncts are true. So in creating your truth table, in the first statement, you list all possible truth values. So you have there true, true, false, false. And on the second statement, you write there all possible truth value. So you have there true, false, true, false. In that case, you can create all possible combination for your truth table. And as we get the result for P and Q, so true, true, that's true. True, false, that's false. False, true, that's false also. And false, false, that is also false. Because remember, in conjunction, P and Q can only be true if both statements are true. Next, we have the disjunction, which can be read as P or Q. The rules is the disjunction of two statements is false only if both disjuncts are false. For example, in the truth table, as we represent the disjunction for the first statement, which is P, so you have there true, true, false, false, and for the second statement, you have there true, false, true, false. Again, we do that one in order to produce all possible combinations. So, as we get the disjunction of these two statements, P or Q is true if you have there true, true. P or Q is true also if you have there true, false. And then P or Q is still true if you have there false, true. And lastly, P or Q is false if you have there false and false. Remember, for disjunction, the disjunction of two statements is always false if both statements are false. Next, we have the conditional or implication, which can be read as if P, then Q. The rules is the implication is true in all cases except when the antecedent is true and the consequent is false. In other words, a true hypothesis cannot imply a false conclusion. So as we construct our truth table for implication or for conditional statements, so you have their P with the values true, true, false, false, and for Q, which is our conclusion, you have there true, false, true, false. And then if P is true, then Q is true, the implication is true. If P is true, then Q is false, the implication is false. Next, if P is false, then Q is true, then the implication is true. And if P is false, then Q is false, the implication is true. Next is biconditional, which can be read as P if and only if Q. Now the rules is the equivalence is true if both propositions are true or if both propositions are false. So as we construct our truth table, so P is true if and only if Q is true. This biconditional statement will give us a true result. Another, if P is true if and only if Q is false, is false. Another, P is false if and only if Q is true. This biconditional statement is also false. And P is false if and only if Q is false. This biconditional statement is true. Again, remember, biconditional statements is true if both propositions are true or if both propositions are false. Lastly, the negation, which can be read as not P. The rules is if a proposition is true, then its negation is false. And if a proposition is false, its negation is true. For example, as we represent this one in our truth table, for our first column, that's our first statement or is our statement. So if the statement is true, the negation is false. If the statement is false, the negation is true. Take note, other symbol for negation is this symbol. Now, let's have our examples. There are two sets of examples. For the first set of example, we are going to determine the truth value of each proposition. For our first example, the negation of P and Q. So in our truth table, you draw there your 4-column table. First column, you label it with P. Second column, you label it with Q. And then on the third column, you label it with P and Q. And last column will be labeled as the negation of P and Q. Now, if P is true and Q is true, the conjunction of P and Q must also be true. And the negation of true is false. Next, if P is true, then Q is false, P and Q is false. The negation of false is true. Next, if P is false and Q is true, P and Q is false, and the negation of false is true. And lastly, if P is false and Q is false, P and Q is false, and the negation of false is true. Next, let's determine the truth value of this proposition, the negation of the implication of W and not V. So as we construct our truth table with 6 columns, and then we label the first column with W, on the second column, V, on the third column, the implication of W and V. On the fourth column, we label it with the negation of V or not V. And then on the fifth column, we label it with the implication of W and not V. And then on the last column, we label it with the negation of the implication of W and not V. Okay, so if W is true and V is true, then the implication of W and V must also be true. Now, as we get the negation of V, its negation is false. And as we get the implication of W and not V, the implication is false. And as we get the negation of false, the answer is true. Next, if W is true and V is false, the implication of W and V is false. And since you have there false for V, its negation is true. And as we get the implication of W and not V, so true for W, true for not V, the result is true. And the negation of this statement is false. If W is false and V is true, the implication is true. And since we have here not V, the negation of V is false. And as we get the implication of W and not V, the result is true. Its negation is false. Lastly, if W is false and V is also false, the implication is true. And as we get the negation of V, that's true. So as we get the implication of W, which is F, and not V, which is true, the implication is true. And its negation is false. Next, on the second side of our examples, we need to express each proposition into a symbolic form, and then we need to find its truth value. So, given, it is not the case that if it is not sunny, then it will rain. We then use the symbolism. We let S be the preposition it is sunny, then R be the preposition it will rain, then the negation of S be it is not sunny. So if S, then R. So if it is not sunny, then it will rain. So as we represent the negation of the implication of that S and R, then in statement it will look like it is not the case that if it is not sunny, then it will rain. So if we try to represent that one into truth table with 5 columns, S for the first column, R for the second column, negation of S for the third column, the implication of the negation of S and R on the fourth column, and then on the last column, the negation of the implication of that S and R. So, we represent our truth tables in all possible combination. The negation of S, so if S is true, its negation is false. If S is false, its negation is true. And as we get the implication of not S and R, so if not S is false and R is true, its implication is true. If not S is false and R is false also, its implication is true. Next, if not S is true and R is true, its implication is true. If not S is true and R is false, its implication is false. And as we get the negation of the result in this column, so the negation of this result is false, the negation of this result is also false, the negation of true is false, the negation of false is true. Now, there are other related implications or conditional propositions that are often used in mathematical logic. These are converse, inverse, and contrapositive. First, we have the converse. Converse of an implication is formed by interchanging the hypothesis and conclusion. That is, if the implication, if P, then Q, its converse is if Q, then P. For example, write the converse of the conditional statement. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So in this conditional statement, we need to look for its converse. So we start with determining what is the first statement, or P. So let P be the statement. Two parallel lines are cut by transversal. Then we'll let Q be our second statement, which states the alternate interior angles are congruent. So as we get the conditional statement, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Since we need to look for the converse, and remember, in converse, if Q, then P. So if the alternate interior angles are congruent, then the two parallel lines are cut by a transversal. So that will serve as our converse in this conditional statement. Take note, you may rephrase the hypothesis and the conclusion for a clearer idea without changing the thought of the implication. For example, this is an alternative way. Let P be the statement. The two lines cut by a transversal are parallel. And then you let Q, the alternate interior angles of two lines cut by a transversal, are congruent. So as we get the implication of P and Q, or as we get if P, then Q, so you have there, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. And as we get its converse, wherein we change the hypothesis and the conclusion, wherein the conclusion becomes the hypothesis and the hypothesis became the conclusion, or the implication Q and P. So if the alternate interior angles of two lines cut by a transversal are congruent, then two lines are parallel. So if we say what's the converse in this conditional statement, its converse will be if the alternate interior angles of two parallel lines cut by a transversal are congruent, then the two lines are parallel. So this is alternative way in stating your statement in your converse statement. Just make sure, again, you do have a clear idea without changing the thought of the implication. Second, we have the inverse. Inverse of an implication is formed by replacing the hypothesis and the conclusion of the implication by their negation. That is, if P, then Q, its inverse is if not P, then not Q. Again, that is, if P, then Q, then its inverse is if not P, then not Q. Now this time, let's determine the inverse of this conditional statement. We used the same example a while ago. So if two parallel lines cut by a transversal, then the alternate interior angles are congruent. We let P be two lines are cut by a transversal or parallel, and then the negation of P or not P is two lines are cut by a transversal or not parallel. For our Q, the alternate interior angles of two lines cut by a transversal are congruent. Then the negation of Q will be the alternate interior angles of two lines cut by a transversal are not congruent. So if we state the implication of P and Q, that's if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Our inverse will be, or not P. If not P, then not Q. So, if two lines cut by a transversal are not parallel, then the alternate interior angles of two lines cut by a transversal are not congruent. I repeat, our inverse will be if two lines cut by a transversal are not parallel, then the alternate interior angles of two lines cut by a transversal are not congruent. Lastly, we have the contrapositive. A contrapositive of an implication is simply the inverse of the converse of the implication. Again, the inverse of the converse of the implication, or the converse of the inverse of the implication. So, if the implication P and Q, or if P then Q, its contrapositive is if not Q, then not P. Now, as we write our contrapositive of this conditional statement, if two parallel lines cut by a transversal, then the alternate interior angles are congruent. Since we have found our P, the negation of P, Q, and the negation of Q, and also we have found the implication of P and Q, and we have also found its inverse, which is if two lines cut by a transversal are not parallel, then the alternate interior angles of the two lines cut by a transversal are not congruent. So our contrapositive, or our if not Q then not P, states if the alternate interior angles of the two lines cut by a transversal are not congruent, then these two lines are not parallel. The contrapositive will be if the alternate interior angles of two lines cut by a transversal are not congruent, then two lines are not parallel. Another example, let's determine the converse, the inverse, and the contrapositive of the given implication, and let's determine the truth value. So, if two angles of a triangle are congruent, then the triangle is an isosceles triangle. So in our truth value, so our hypothesis is our P here is two angles of a triangle are congruent. Then our conclusion, or our Q, is the triangle is an isosceles triangle. And it is also true. Now, for the negation of P, so if our statement will be the two angles of a triangle are not congruent, which is false, and the negation of Q is the triangle is not an isosceles triangle, that's false. Our implication will be if two angles of a triangle are congruent, then the triangle is an isosceles triangle. That is true. For the converse, so if Q then P, we have there if the triangle is an isosceles triangle, then the two angles of a triangle are congruent. That's true. For the inverse, you will have there if not P, then not Q. So for our statement, that will look like if two angles of a triangle are not congruent, then the triangle is not an isosceles triangle. That's true. And then for its contrapositive, wherein we say if not Q then not P, states that if a triangle is not an isosceles triangle, then the two angles of the triangles are not congruent, which is true. That would be all. Thank you, math learners. You may proceed to the next video.